Hey there. The purpose of this video is to walk you through the steps in StatCrunch to talk about scatter plots and regression lines. You can do all of this in the StatCrunch website. So if you want to follow along with me, pause your video, get on to MyStatLab, click on StatCrunch. Afterwards, I'm going to actually click Data Sets from your textbook and go to Chapter 9. I want 9.2, number 24. Now you'd actually have to look in the book. I think that this data is the calories from a particular cereal and the amount of sugar in the calories. It's accidentally dumped all of the sugar values, however. You see right here, it dumped it in the wrong column, but we'll deal with it. Okay, now you can go to graph and click on scatter plot to just get the graph. But if you'll go to stat, you can get the graph and the line and the equation for the line and your correlation coefficient. So I'm not expecting you to calculate any of this by hand. So I clicked on stat, click on regression, choose simple linear regression, tell it your x variable is your calories and your y variable is your sugar. In this case it was in column 3. And then just click compute. You get all kinds of information here that you may or may not want. You just need to pay attention to, honestly, this very first batch of information. The rest of this has to do with hypothesis testing, and we're not doing that in this course. But if you notice at the bottom, there's an arrow, which means there's page 2, and page 2 has your actual graph. So again, you can go to options, and you can edit and save and copy and print. I've already done that for us, and I've dumped both the information on page 1 and the graph from page 2 into my OneNote notebook. So I just want to talk about what the results look like. And then I'll go through the keystrokes with you one more time. So the simple linear results, the way they give this information to us is they actually use the variables that we typed in. So instead of using y, they're using variable 3. And it's equal to this -18 plus this 0.167-ish times the calories. So we would probably write it as y equals mx plus b. So if you wanted to change how that was written, it would be y equals 0.17x, I rounded a little bit, minus 18.14. Now, I happen to use this notation, this y hat notation, to mean the predicted y's instead of the observed y's. The strength of your line depends on this r. It's your correlation coefficient. The closer it is to 1, the stronger the line is. So since r is about 0.75, we have a fairly strong line. Okay, so let me take a look at this line for a second and have a little bit of a conversation. This line gets created by making these distances from the line to the graph zero out. So everything that's above the graph should be the same distance as everything below the graph. This distance is called a residual. And the residual should sum up to 0. So the ones below the graph are negative values and the ones above the graph are positive values, and when you sum them all up you get nothing. Now you can tell from looking at this graph that there's a positive relationship. The more calories you have, the more grams of sugar you have, and if I was doing this graph myself, I would actually label this sugar and I'd put it in grams here and maybe give a title to the graph for values in cereal or something like that. Now, why do we create these lines? We create these lines to make predictions. So I need to copy this line. So let me make this a little bit smaller for a second. So I need y, the predicted y is going to be 0.17x minus 18.14. And we want to use it to predict how much sugar would be in a cereal with 170 calories. So we take a look at this. predict the value. Sorry if there's some dead space there. I'm having problems with my computer today. Okay, I'm probably having problems with myself. So I end up with a predicted value of about 10.76 grams or 11 grams. Now if you come in, you can see we have some observed values here that are lower than the 11 grams. So that 11 would actually be the value that falls on the line, and these are the two observed values that we saw at 170 calories. Some other questions that you might be asked is, what is the slope and what does it mean? So your slope in this problem is 0.17 or 17 over 100. So the way to interpret that is, on average, for every 100 calories that your cereal increases, so we increase the cereal by 100 calories, then on average we're increasing the sugar by 17 grams. That's one way to look at it. You can also look at more rounded values like 0.2. 0.2 would be the same as 1/5, so you could talk about every 5 calories you have 1 gram of sugar increase. So you can choose different ways to break out the slope, but the slope has to do with a rate of change, and it compares the y's to the x's. Okay, so what does the y-intercept do? Well, the y-intercept for this graph is the negative 18.14, and that happens when x is equal to 0. Well, in our case, that would mean that a 0-calorie cereal would have negative 18 grams of sugar. That doesn't make sense. So sometimes your y-intercept means absolutely nothing. Just saying. Okay, so let me go back and show you where I got all this again. I used one of the data sets from the textbook. I came into StatCrunch. I went to Stat, Regression, Simple Linear Regression, and then told it my x and my y variables, and I clicked Compute. That's the best way to do any of your things that you need to do in Chapter 9. And I hope you found this video helpful. Now I have to figure out how to turn it off.